Hi children, today we are going to learn 8th class 6th chapter, that is square roots and cube roots. So here I would like to tell you what is meaning of square and square root first. Okay, here the definition of the square, that the product of two same numbers is called as a square. The product of two same number is called as a square. So suppose 1 into 1, that equal to 1. So 1 square is 1. 2 into 2, product of two same number is 4. So 4 is the square of the 2. So 3 into 3, 9. So 9 is a square of the 3. So what is meaning of a square root? That I will tell you. See here I have written some square and square of the number. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square 25. That means 5 into 5 is 25. 6 square 36. If power is 2, that is called square. 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225, and 16 square 256, 17 square 289, 18 square 324, 19 square 361, 20 square 400, 21 square 441, 22 square 484, 23 square 529, 24 square 576, 25 square 625. That means 25 into 25 is 625. Similarly, 26 square 676, 27 square 729, 28 square 784, 29 square 841, 30 square is 900. So till 30 squares I have written here. So more than that also we need to learn. So mainly we must know that we should bias this up to 13 squares. This will help us in the problems very well. Okay, here you need to observe. Did you observe the unit place of the square of the number here? The unit place 1 4 6 5 6 9 4 1 0 1 4 9 6 5 only, but we cannot observe 4 digits here, the unit place of the square of the number. That 4 digits are here. The perfect square never end with the digits 2 3 7 and 8. The perfect square will never end with the digits of 2 3 7 or 8 in the unit place. A perfect square will never end with the unit digit with 7, 2, 3, 7 and 8, and also single zero. So a perfect square will never end with a single zero. Here it has double zero, two zeros. It will never end with 1 0. If a perfect square is ending with a 1 0, we can say that it is not a perfect square. If a number ending with a 1 0, only with 1 0, that means it has only 1 0. The number having only 1 0, that means it is not has a 2 0. Suppose here you have written a 0. This number is ending with only 1 0. It is not a perfect square. Easily directly you can say that. If a number ending with a digit 2, 3, 7, 8 and a 1 0, then they are not a perfect squares. Directly we can say that. Okay, and the square of the even number is always even number. 2 square is 4. 4 is a even number. Square of the 4, 16. 16 is a even number. 6 square, 36, even number. Your square of the even number is always even number. The square of the odd number is always odd number. The square of the even number is always even number. The square of the odd number is always odd number. And here, if you observe, 1 square is 1, the unit place. And 9 square is also, the unit place is 1. So, the unit place, ending with the unit place. 1 square is end with the unit digit 1. And 9 square 81, ending with the unit digit 1 only. Let us suppose 11 square, the 1 is ending with only a 1. Suppose let us take 19 square is also ending with a 1. Okay, if the square of the number, if the unit place of the square number is 1 or 9, the unit digit will be 1 only. If 2 and 8, you observe the 2 and 8, the unit digit will be 4. 2 and 8, the unit digit is 4. 3 and 7, the unit digit is 9. 4 and 6, unit digit is 6. 5 is always 5. See that 5 square is 5. 15 square is 225, 5. And here 25 square, 625. So always the square of the 5, the unit digit always will 5. So these are the things we need to be remembered in the square of the numbers. So let us learn the square root of the number. If you know the square of the number, we will know the square roots. See that if a square of the number expressed as a product of two equal factors, the product of two equal factors, then one of the factor is called as a square root of the number. Suppose see the square root of 1 we can write as a 1 into 1. So one of this number is called as a square root of the number. This square root of 4 we can write 2 into 2. So one of the factor, two equal factor, I have written as a product of two equal factors. So one of the factor is known as a square root of the number. 9 we can write 3 into 3. So one of the 3 is known as a square root of the number. See, 1 square is 1, 2 square is 4, square root of 4 is 2, square root of 3 is, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. So if you know the square of the number, you will know the square roots of the number. So just learn till 30 squares and 30 square roots. If you know the squares, you will know the automatically square roots. So square root of 25 is 5, or 5 square is 25, 6 square is 36, or root 36 is 6. So in this way we can remember. So this is what you need to be remember. These are the basic points to do the exercise 6.1 and also 6.2 and 6.3 based on only this. So let us see some problems based on these squares and square roots. The different methods we'll learn. So this definition, square definition, square root definition, up to 30 squares, up to 30 square roots. Just you by it. You try to remember that up to 30 squares and square roots. So here we go for the exercise 6.1. The 6.1 is a general about the what I told you, what the information I told you just before. The general information will be there in the 6.1. What will be the first bit? What will be the unit digit of the square of the following numbers? Unit digit of square of the following numbers. First one, 39. The unit digit of the square of the 39. The unit digit of square of the 39 equal. Square of the 39 is here 9 square. The unit digit will be 1. 199, 9. Here I have written a box the same way here. So next, second one is this 297. The unit digit, of square of 279. Here 7 square you do it, that you will get 9. So 3 and 7 will end with the unit digit 9. I told here 199 will end with the unit digit 1. 2 and 8 end with the unit digit 4. 3 and 7 end with the unit digit 9. 4 and 6 end with the unit digit 6. 5 end with the unit digit is 5. 1, 2, 3, 4, 5. 9, 8, 7, 6 or 5, 6, 7, 8, 9. In this way you remember. Okay, next third one. Only one unit digit we have to write. 5125. The unit digit of the unit digit of square of 5125 is always 5. 5 always went with the unit digit 5 only. Then next 7286. The unit digit of square of the 7286 is 6. The 6 always end with the digit 6. Okay. Then the last one of this bit 8742. The unit digit of square of the 8742. 2 end with 4. So this is the answer, simple. So this code, if you remember, this answer you can write. See that according to the code, here written it. So do not to do the squares and see the last unit digit. Here directly, if you remember that code, you can write that. Yes, the second bit here. Yes, which of the following numbers are perfect squares? Here I have given 121. The second one 136. Third one 256. If you know up to 30 squares, then you can write this. That's the reason I told you up to 30 squares. Okay, see, in the up to 30 squares we have know that here 121 and 256 are perfect squares. Are perfect squares. The remaining are not a perfect squares. So the remaining are not perfect square here. Then third bit, the following numbers are not perfect square. Give the reason. So here the following numbers are not perfect squares. The given questions are not perfect squares, he said, but give the reason why they are not perfect squares. The third bit question, the first question is that 257. It is not a perfect square. Why 257 is not a perfect square? Because the unit digit end with 7. The unit digit is 7. A perfect square never end with the digits 2, 3, 7 and 8. 2, 3, 7 and 8 are a single zero in the unit place. Okay. If these digits are there in the unit place, they are not a perfect squares. Directly we can say. Okay. Then here it is not a perfect square. 257 is not a perfect square because the unit digit of the number is 7. But a perfect square never end with the unit digit 7. But a perfect square never end with the digit with unit digit 7. This will be the answer. The next question is in this, the second question. Third bit, the second question is 4592. 4592. Here 4592 is not a perfect square because the unit digit of the number is 2. But a perfect square never end with the unit digit 2. Simple. The same reason will come here. As I told you that a perfect square will never end with the digits 2, 3, 7, 8 and single digit of 0. And the next one 2433. Yes, here also same. 2433 is not a perfect square because the unit digit of this number is 3. The perfect square never end with the digit 3. And next 5550. 5050. So here 5050 is not a perfect square because the unit digit of this number is end with only a single zero. Okay, end with is a single zero, a single zero. But a perfect square of number never end with a unit digit, a single zero. See, 10 square is 100. You will get a 2 zeros. Here, then you go for, suppose 20 square is 400. You will get a 2 zeros. 30 square you will get a 900, 2 zeros. But you will never get only a single zero in the unit place. Suppose 2560. It is not a perfect square. So like that. If a digit is end with, if a number is end with only a single zero, it is not a perfect square. Directly we can say that. Okay. Now next, the last question of this bit, the fifth one, 6098, 6098. 6098 is not a perfect square because the unit digit of the number is 8 and a perfect square never end with the unit digit 8. Finish. Okay, this is the third bit. The same reason will appears, but see that a perfect square never end with a 2, 3, 7 and 8 with a single digit 0 also. Then the fourth bit of exercise 6.1, find whether the square of the following numbers are even or odd. Even or odd. Simple. The first one, 431. Square of this number is even or odd. The square of the 431 is odd because the unit digit is because the square of the odd number is always odd, because the square of the odd number is always odd. The square of the odd number is always odd. The square of the 431 is an odd number, so square of the 431 is also odd number. Next, the second one, 2826. The square of the 2826 is even because it is a even number. The square of this number also even number because the square of the even number is always even. Yes, in the same way we have to do the remaining. So let me do that. Fourth bit, first one, second one completed. Now third one is given. The third one, 8204. 8204 is a even number, no? So the square of the 8204 is a even because the square of the even number is always end with even number. Then here they are given fourth one, 17779. Yes, it is a odd number, so the square of this 17,779 is a odd. Now next, the given number is 99,998. The square of this 99,998 is a even number. So the square of the even number always end with an even number. This is the fifth one. So this fourth bit is also completed. Just general knowledge, just introduction class. If you listen, this all you can do it by your own. Yes. Now next, question bit number 5. Bit number 5. How many numbers lie between the square of the following numbers? So here to do that, we have one box in the previous page. The just before of this exercise there is the previous page. Just you go through this box so that you will be know that. So here they have given how many numbers lie between the square of the following numbers. That means here they have given first question 25 and 26. Okay, 25 and 26. Between 25 square and 26 square, how many numbers are lie? That means how many numbers are there between 25 square and 26 square. So we know that 25 square is equal to 625 and 26 square is 676. So between these two numbers, how many numbers are lying? That means how many numbers are there between this? To do that, it's a big process. So what we have to do, there is a one formula here. Yes, this we have to use it. 2 into base of first number. 2 into base of first number. Here it is a base number. 25 we call as a base number. So the number of the number of numbers lie between 25 and 26. 25 square and 26 square. 26 square is equal to 2 into base of the first number. Base of first number. Base of the first number here. 2 into base of the first number is, that is 25. 2 into 25 is 50. So there are 50 numbers lie between these two. There are 50 numbers are lying between these two. 25 and 26. In the same way, here this we did not write. Just if you write this answer is enough. Okay. Now the second question is that just they are asking that how many numbers lie between the given numbers. Here 56, 57. The number of numbers lie between 56 square and 57 square is 2 into base of the first number. Base of the first number is here 56. 56 into 2, 2 6 are 12, 1 carry 2 5 are 10 plus 1, 12. 112 numbers lie between the 56 and 57 squares. So in the same way we have third one now. 107 and 108. Okay, how many numbers lie between this 107 and 108? 2 into base of the first number, that is 107. Okay, base number is 107. 2 7s are 14, 1 carry 2 0 0 1 2. 214 numbers lie between these two numbers. Simple. So this is a formula you need to be remember. 2 into base of the first number. Again, if you need more examples, it is there in the before the exercise in the page. Here you can see the remaining all the formulas also. And the last bit. Yes. Without adding, find the sum of the following numbers. Without adding, find the sum of the following numbers. Here 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 equal. It is very easy. Just see the trick. What we are going to use it. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus odd numbers. Consecutive odd numbers we are taking. The consecutive odd numbers. Consecutive in the sense next immediate odd number. 1 after 3, 3 after 5, 5 after 7. That are the consecutive numbers. Just you need to be thinking how many digits are there. 1, 2, 3, 4, 5. So 5 square no? Is it? 5 digits are there. 5 square equal to 25. The sum of this is 25. Simple. 1, 2, 3, 4, 5. 5 digits we are adding. So 5 square is 25. It only happens in the sum of the consecutive odd numbers. The sum of the consecutive odd numbers. The case of sum of the consecutive odd numbers is 1 plus. See that. Now how many digits are there? We will count 1, 2, 3, 4, 5, 6, 7, 8, 9. So here 9 square equal to 81. Simple. The sum of these all numbers equal to 81. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here 13 square you have to take. 13 square is 169. The sum of these all equal to 169. Without adding, we are telling the sum. This is what they asked. So this is a trick you need to use to find without adding. It's only possible when sum of the consecutive odd numbers are given. So I hope you understood this exercise number 6.1. In our next video, we'll meet with the exercise number 6.2. Thank you.